Context engineering. The term showed up about a year ago, and it is now in every job description, every conference talk, every thread about why somebody's agent stopped working. Most of the explanations you'll find are a list of tips. This is not that. By the end of these 15 minutes, you'll know exactly what the thing is, why it exists, and the 4 operations that make up all of it. Not vibes, the actual mechanism. Let me start with something you have probably lived through. You build an agent. You test it, and it is genuinely good. It reads the files. It makes the change. It explains itself. Then you use it for real work. 20 turns in, 30 turns in, it starts repeating itself. It edits a file it already fixed. It forgets the constraint you gave it at the very beginning. And here is the part that matters. You changed nothing. Same model, same system prompt, same code. The only thing that changed is what was in the context window. So you reach for the obvious explanation. The model isn't smart enough. Time to wait for the next one, or switch providers, or add another paragraph to the system prompt telling it to be careful. I want to convince you that this diagnosis is wrong almost every time. The model is fine. What went wrong is the working environment you handed it. And unlike the model, that part is entirely yours to design. That design job is what context engineering means. To fix the environment, you have to know what it is, so let's be concrete. When you talk to an agent, it feels like a conversation. You say something, it answers, you say something back. That is an interface illusion. What the model receives is a single, flat block of tokens. Your instructions, the tool definitions, everything said so far, the contents of every file it opened, all of it laid end-to-end in one sequence. There is no memory between calls. There is no session. The model sees this block, produces the next tokens, and forgets everything. Which leads to a consequence people consistently underestimate. If the model remembers nothing, then to continue a conversation, you have to resend the conversation. Every turn, in full. Turn 2 sends turn 1 plus the new message. Turn 10 sends all of it again. Turn 30 sends everything that has ever happened in that session, from the top, as if for the first time. There is no follow-up question. There is only a longer and longer block of tokens, rebuilt and resent on every call. So what is actually in that block? Let's take it apart on a realistic agent turn. First, the system prompt. Who the agent is, the rules, the formatting, the safety instructions. A couple of thousand tokens before anything has happened. Then the tool definitions. Every tool you gave it, with its full schema and description, sent on every single call whether it is used or not. Then the conversation history, which only ever grows. Then the file contents, the search results, the command output, the biggest slice by far, and the one you control least. And then, at the very bottom, the thing you actually asked. Somewhere around 1% of the window, everything above it is competing for the model's attention. Now, the obvious objection. Modern models have enormous context windows. 200,000 tokens, 1 million in some cases. Surely this is a solved problem? It is not, for 2 reasons. The first is that the window is a hard wall. Cross it and the request fails, or something silently gets dropped. The second reason is the one that actually bites, and it is the whole reason this lesson exists. Quality degrades long before the window fills. A context can be legal and still be terrible. Here is the first failure mode, and the most counterintuitive one. Plot how well a model finds a specific fact against how much context surrounds that fact, and the line goes down. Not off a cliff at the limit, steadily, from very early on. The reason is that attention is a finite resource being spread across everything you sent. Every irrelevant token you add is another thing competing with the one line that actually matters. And the information was in there. You can scroll up and point at it. The model just read past it because you buried it. That is why this bug is so miserable to diagnose. Nothing is missing, nothing errored. The answer is simply worse. Failure mode 2. Early in a session, the agent gets something wrong. It guesses at a function name that doesn't exist, or misreads a config value. Small mistake. But remember what we established. History is resent on every turn. That wrong fact is now part of the permanent record, and the model has no way to tell the difference between something it verified and something it made up 8 turns ago. It reads its own guess as established truth, so it builds on it, and every turn after that inherits the error, compounds it, and resends it. This is why an agent can sound completely confident and completely wrong for 20 turns straight. Failure mode 3. You connect your agent to everything. A dozen servers, 40 tools, because more capability has to be better. But every tool you add does 2 things. It spins window on a schema that gets resent on every call, used or not. And more importantly, it adds one more plausible-looking option the model has to choose between. Choice is not free. Past a certain point, the model starts reaching for the wrong tool, or calling 3 when one would do. Teams routinely get better results by removing tools, which feels wrong right up until you try it. So that is the problem in 3 shapes: dilution, poisoning, distraction. Now the good news, which is that the solution space is much smaller than the internet makes it look. Strip the branding off every technique, every framework, every blog post with a number in the title, and you find 4 operations: write, select, compress, isolate. That is the whole toolkit. Let me take them one at a time. Operation 1, write. The idea is almost embarrassingly simple. If something needs to persist but doesn't need to be read on every turn, put it outside the window. The agent writes its plan to a file. It records what it tried and what failed in a scratch pad. The window then holds a single line saying where that file is, instead of the file itself. Every project notes convention, every memory directory, every scratchpad pattern you've seen is doing exactly this, trading an expensive resource for a cheap one. Disk is unlimited and costs nothing. Attention is finite and costs everything. Operation 2, select. Given everything you could put in the window, put in only what this turn actually requires, not the whole file. The one function, not the entire history, the last exchange, plus the handful of earlier decisions that still constrain the work. This is what retrieval systems do, and it is also what a good file search tool does, and it is what you are doing when you decide that only 3 of your 40 tools should be visible for this particular task. And notice where the difficulty actually sits. Finding relevant material is the easy half. The skill is in leaving things out, which is uncomfortable, because everything you exclude is something the model definitely won't know. Operation 3, compress. When history has grown too long to keep but is too important to drop, you replace it with a summary of itself. 20 turns of exploring a code base become 1 paragraph. Here's what we learned, here's what we ruled out, here's the current state. Thousands of tokens become a few hundred, and the useful conclusions survive. This is exactly what a long agent session is doing when it compacts itself in the middle of your work. But be clear-eyed about it. Compression is lossy on purpose, and the loss is where your bugs will come from. If the summary drops the constraint you gave in turn 3, the agent will cheerfully violate it in turn 40 and have no idea it ever existed. Operation 4, isolate. Some subtasks are inherently messy. Searching a large code base, reading 12 files to answer 1 question. Doing that in your main window fills it with material you will never need again. So you hand the job to a separate agent with its own clean window. It burns 30,000 tokens rummaging around, and it returns 400, just the answer. The main context never sees the exploration, only the conclusion. This is the real reason multi-agent systems exist, not because agents are better in groups. Because a subagent is a disposable context window, and you get to throw it away when it's done. This is also the cleanest way to see why the industry quietly stopped saying prompt engineering. Prompt engineering treats the problem as wording. Find the magic phrasing, tell it to think step by step, promise it a tip. It is a string, and you write it once. Context engineering treats the problem as what the model can see at each step. It isn't a string. It's a system, and it runs on every single turn, assembling, selecting, compressing, discarding. The prompt is one component inside it, and usually not the interesting one. If you keep one thing from these 15 minutes, keep this. The context window is working memory, and you are the one allocating it. Nobody else is. The model will use whatever you hand it, uncritically, including the junk. So the question to ask about every token is not, can this fit? It fits. The window is huge. The question is whether it earns its place, because everything you add makes everything already in there slightly harder to see. 2 honest caveats before we finish. First, this field moves quickly. Context windows keep growing, and models keep getting better at using long context. But every time that has happened so far, the tasks have grown to fill the space, and careful curation has never stopped paying. Assume the specific numbers in this lesson will age. The 4 operations won't. Second, and more practically, don't over-engineer a short task. If your agent does one well-defined thing in 3 turns, put everything in the window and get on with your life. Everything here starts mattering when sessions get long, and it matters enormously by turn 50. So that's the whole picture. The model is stateless, so every turn resends everything. The window fills with system prompt, tools, history, and files, and your actual question is the smallest part of it. Too much in there and the model dilutes, inherits its own mistakes, and drowns in options. And you fix all of that with 4 operations. Write it out, select what's needed, compress what's finished, isolate what's messy. Next time, we take the failure I glossed over, why your agent forgets, and look at exactly what survives when a context gets compacted and what quietly does not.